All right. Hi, everyone. My name is Megan, and I'm currently a data scientist at Sobeys, which is one of Canada's largest grocery chains. I code in mostly PySpark and Python in most of my career. I've built recommender systems. I've deployed multiple experiments and also designed multiple experiments, done a bunch of A/B testing ones, and I contribute frequently to my internal data science tooling at the various companies that I've worked at. And my talk today is going to be about simplifying testing of Spark applications. And the reason why I wanted to talk about this is because I've learned about the usefulness of testing and a little bit more about Spark in depth recently. And when you put them both together, testing in Spark does lead to a couple of difficulties, which I will go over soon. So how did I come to know Spark? Spark allows you to work with very large data sets, and Spark became a natural tool for most of the companies I work for due to its great ability to scale large data sets. And you can, perform feature engineering tasks a lot more quickly, even some model training and scoring also decently fast. And Spark is also an open source tool, and you'll find lots of contributors ranging from various companies like Apple, IBM, and even global contributors as well. So I mostly work with PySpark, and PySpark allows you to write Spark applications using its Python APIs. PySpark supports most of Spark's features like Spark SQL, data frame, streaming, MLlib, and the Spark core. And the reason for this API is because Spark is written in actually Scala, and its source code can be compiled to Java bytecode, and then it has to be ran on the JVM. So the main takeaway here is that PySpark is not Python native. So that might face a bit of a problem for data science applications because, in data science, as we all know, we love coding in Python. There's tons of packages, Pandas being the most popular. It has, good documentation, decent functionality, and a really great community of people who can help answer questions. And even solve problems that have already been solved. So for example, on the chart on the left, you can see the percentage of Stack Overflow questions tagged by Pandas is high relative to the other Python packages. So when it comes to maintaining both Python and Spark logic, Python being it has to run on the Python interpreter, and Spark being it has to run on the JVM, it's good to think about what kind of data that you need to test with and what kind of logic you need to run with. So are you ingesting data? And then it helps you also think about what kinds of tests that you want to run. Firstly, are you ingesting data from your data lake where everything's mostly in Spark data frames and you're running a like end-to-end integration test with Spark data frames? Or are you running a smaller unit test on a small modular data set, mock data set in, say, Pandas? Or are you also running a bunch of data validations where the data is in Spark data frames and whatever logic that you want to test with, right? So let's say we break it down to 4 scenarios. And on the columns, we have the type of data that you're looking to ingest. And on the rows, you have the logic you want to process your data with. So on the top left, it's the easiest thing that you want to do. Everything runs in the Python interpreter. There's no cluster spin up. Your Pandas data frame is processed by Python logic. Everything's Python, and we're all happy there. On the top right, this is, I would say, one of the most common scenarios where the company that you're in is already adopted like a data lake and it has a bunch of Spark servers. So the logic that you have to, the data that you're ingesting are naturally Spark data frames. But naturally, you would have people wanting to write in Python logic. So unfortunately for this one, you'll have to still spin up a Spark cluster in order to ingest your Spark data frame. But in order to run your Python logic, you might have to convert your Spark data frame to a Pandas data frame, and that can be really expensive. So what some people do is they actually do something the other way around, where they wrap their Python logic in a UDF so that it can run on the Spark JVM. And I can talk a little bit more. I'll talk a little bit more about this later on. But all in all, still a little bit more expensive to test, where you have clusters spin up and you also have to convert your data frames. And then in the bottom left, this quadrant might not make sense to some people, but it actually does have a use case here. So let's say you want to run a test and the mock data set that you are ingesting is a pandas data frame, and the logic that you're running with is PySpark logic. So once again, there's like a mismatch of like, okay, my data has to be processed in Python, but then logic is in Spark JVM. So you're going to have to, spin up a Spark cluster firstly in order to run your Spark logic, but then also convert your pandas data frame to Spark data frame. So also expensive to test. And then you come to the bottom right where, Spark and Spark, we're all good here. You just have to run into the cluster spin up, and it's okay to test. Like spinning up a local cluster takes it takes some time, but it's easier to test than the other top right and the bottom left. Ideally, you would want to move towards the top left quadrant, because you have absolutely no cluster spin up, no conversion of like any data frames and whatnot. And you'll be avoiding any of those two things. So I want to circle back to Spark and Pandas UDFs, because that may be something that you're looking to do where you have a bunch of Python logic that you want to run on Spark. And if you Google, how to run Python logic on Spark, most of the time, these are the things that you'll be shown. And I wanted to dive into that a little bit more. So the Apache Spark project is also highly aware of the popularity of Python, and they've even improved the UDFs over time. So the UDF here that I'm talking about is the PySpark UDF, and it stands for user defined function. And prior to Spark 2.3, it was one of the ways that enabled users to run their Python logic on Spark so as to extend any PySpark functionality that didn't exist at that point of time, or your Python logic is a little bit more readable than, say, PySpark logic. So Spark, like I said, it's not able to translate that Python code from the UDF to the JVM. So the Python UDF has to be executed on the Python worker, unlike the rest of your logic that has to be rest of your Spark job that might have to be executed on the JVM. So with that, this transfer is realized by converting the data to pickled bytes and then sending it to Python, which is not very efficient and has a really big memory footprint. And over time, this process became really expensive because it has to be done one row at a time, because Spark doesn't know what your function is like. So to be safe, it just does everything one row at a time. But in Spark 2.3, it got a lot better, and Spark released the Pandas UDF. And in order to save on the exchange of data between the JVM and Python, it relies on Apache Arrow in order to do that. And it has almost zero deserialization there. So here's a benchmark taken from the Databricks blog, where it showcases 3 different kinds of functions where the Pandas UDF beats that vanilla PySpark UDF. And yeah, you can see, like, the shorter the better. The Pandas UDF outperforms that in all 3 of those benchmarks. So to use these Pandas UDFs, it can be pretty confusing as well. In this simple use case, you would have to add 1 to like this arbitrary function where you have to add 1. You could do so in any of these 3 ways and it'll give you the same outcome. However, each of these Python UDFs kind of expect a different input and output type and works in a different way with a distinct semantic and different performance as well. So as you can see here, these top two functions, you're able to run it with the select and with column PySpark APIs. That works, but then it doesn't work when you do a group by. But then at the bottom one, you see that it kind of fails with the select with column and even this like specific group by syntax, but then it works with this one. So, Apache Spark kind of noticed that it was confusing to users. So what they did in Spark 3.0 is they released the better pandas and series type hinting. So now you don't even have to, tell what kind of return type it is. You can just give like this very Pythonic type hint of series, even iterator and data frames. So these three ways of writing the UDFs can now be written on the right. And you totally don't need to spin up any cluster in order to run this specific function because it's totally Pythonic as well. I would even say that, actually, before I go to that, so one thing that people like to do with those functions is still decorate it because it's a lot prettier. Rather than separating it out onto a separate line and wrapping that function with the pandas UDF. But I would say that testing the undecorated function is a lot easier. You can still access this internal undecorated function, but you'll need to read a little bit of source code in order to do that. But this is one step closer to being a little bit more Pythonic and closer and abstracted away from the Spark execution engine. And I would even say the functional APIs got better. So this, once again, totally Python, native Python syntax. And all you have to do is call on this functional API to process your Spark data frame, and that would work. So another note about Databricks and Databricks Connect. Databricks was founded by the original creators of Apache Spark, and Databricks allows users to spin up their own Spark clusters at a click of a button. And they offer a tool called Databricks Connect, which is a client library for Databricks runtime. It also allows developers to write jobs using the Spark APIs, run them remotely on the Databricks clusters. And this is really useful for developers like me, where I prototype my code in like VS Code or any IDE, but then locally, but then I can execute all of that remotely. So I use this tool on a daily basis, really, really like it. However, one downside about when it comes to testing implications is that it hijacks your PySpark, which means that running your tests may now take you as long as spinning up a remote cluster. So that means running a simple unit test might take you like 10 minutes because of the cluster spin up. So one way we can test quickly with native Python or pandas execute on Spark when needed is through Fugue. And Fugue is an abstraction layer that keeps your code and computation native to Python, yet easily portable to Spark and even Dask. And you don't, and developers that use Fugue benefit from more rapid iterations of their data projects because they don't even need to spin up a cluster unless warranted. So now I will go through a demo that I've prepared where I will showcase how you would do something, how you would tokenize some comments that I got off Kaggle using a pandas UDF versus Fugue. So in this Kaggle competition, I guess competitors were given comments to process, and they were supposed to, and this was a multi-label type task where a comment could be labeled toxic or bad or a bunch of other labels as well. And one of the main, I guess, like a very common feature engineering task of any NLP pipeline would be tokenizing. So I would go through kind of that feature engineering task in the UDF and versus Fugue. So over here, I have loaded the Kaggle competition data, and this is an example of a comment. This guy seems very passionate about whatever he's talking about, this hardcore Metallica fan. So we want to process this comment into tokens, which is to have them separated out into words so that you can run it on any other, so that you can, train a model or do whatever with it downstream. So we have the UDF version where this tokenized function takes in a parameter. And as you can see here, this parameter is actually has one of the ways to allow UDFs to take in a parameter is by broadcasting that variable so that it's available on any worker that needs to access it. Another way you could do that is by just wrapping another function on top of your tokenized UDF where that takes in a parameter. But once again, it's not as much simpler, but one of the ways. And what this function does is that it removes, first it changes everything to lowercase, removes any punctuation, it splits words on the space, obviously. And then this one I added, it's further splits on the new line character, because in this case, there wasn't a space here. So I wanted to separate those two words. And then removed any non-ASCII words, and also removed stop words where the corpus I got from was NLTK, which is up here. And then it returns that new, I guess, the new array of tokenized words. So as you can see here, we would run that. And it's firstly converting the data frame into a Spark data frame so that we can run our UDF together with it. And there you have it. So this was the original comment, and now we have the tokenized words out here. This is another comment that we get, and we also see that it got a bunch of tokens as well. Okay, so that worked. We had to spin up a Spark cluster, not ideal for testing, but it worked. So let's see how this looks like if we were to use Fugue. So we go through the same kinds of tasks again. Remove punctuation, lowercase, yada, yada. The one thing that is slightly different here is that instead of that pandas UDF decorator, we have to define the schema. Fugue needs to know what the output type looks like. So that's something that we have to declare here. But other than that, everything is, this is like totally a Python function. And now let's say you want to run this on Spark. So first we'll just showcase that, this is totally in pandas. Oops, did I not run that? Input call, did I? Oh, okay, so right. So yeah, so that runs. This is the pandas version. If you were to not use Spark, this is how it looks like, and you have all of those tokens. Really nice. So now we want to run it on Spark. So with Fugue, you would have to first instantiate a workflow and then pass in the data frame that you want to process. And then over here is where you would pass in the function that you want to run. So let me delete that. And you can pass in parameters this way, and then you do a dot show. So when we run this, you would see nothing runs. So the reason why that happens is because we are just, I guess, adding on steps to the workflow. And in order for the DAG that we instantiated to run, you would need to do a dot run. So let's run that. And in this case, this runs on the Python execution engine. So as you can see here, it processed everything in a pandas data frame. It was able to also tokenize those comments. And yeah, everything seems to work. And if you compare that to over here, it looks like it's pretty much the same thing as well. Yeah. So let's say you want to bring this over to Spark. So all you have to do is run that. And it's spinning up the Spark cluster now. And ta-da, now it processed everything as a Spark data frame, and you still have those tokens as well. So really, really nice. So one thing about this is that you would realize that with the UDF, you were able to create the column name in here. You're also going to be able to do that in the tokenize function. So very similar to remove punctuation, you would just put input call string, and then you would change this to input call, run that, and then make sure that you pass in that parameter as well to stir, and that should also work. Why are we getting an error? Oh, silly me. Okay, there we go. So that works as well. So yeah, that's pretty much how Fugue is able to take in extra parameters as well. Obviously, you can run both side by side. You can even see that it processes it in separate ways, pandas and Spark data frame, and you can compare the differences, or you can compare that they should be also consistent with each other. So yeah, I've kind of come to the end of my talk. You know, we have a link to our tutorials. You can also Slack us. We would love to hear your feedback on the framework. And yeah, that's all for my talk.
Yes. What I guess speed is the first thing when to think about. So I guess how is the speed up when you're not using the Spark cluster versus this Fugue by itself?
The speed up. I guess you would save yourself on the cluster spin up. I think as you saw, it was a couple of seconds back there. I would say that, you know, if you have like a bunch of functions, a bunch of like Python functions, it would also save you on, you know, doing that. Yeah, I would say mostly the cluster spin up. I don't know, Han and Kevin, what are the other advantages of that? I think they would be able to talk to even like the partitions and whatnot. Yeah.
Yeah, so for execution, so for example, if you are processing a small data frame for testing, then the overhead for Spark is very significant. You need to spin up the cluster, and also you have to partition the small data frame to even smaller, and then to process. And also you have the communication overhead between Python and JVM, right? So that's overhead. And actually there is another type of speed, which is development speed, right? So how can you improve your development speed? That is, you have to be able to iterate quickly. And Fugue will let you iterate quickly because you can test your data with just a small data frame without Spark, and then verify everything works. And then you can spin up a Spark cluster and run on the bigger data frame. So you can quickly iterate on small data frames, on small data sets, and until you are confident. And then you can bring the logic to the real Spark cluster. That's another type of speed up. It speed up the development.
Thanks. It's another question I have. I guess have you used Databricks, or like how does that help your workflow? Like what's the correlation with using a platform like Databricks?
Yeah, so like I said, I think Databricks Connect, I really like that tool. It helped me a lot in, you know, I'm very used to coding in an IDE. The downside about that is, you know, that cluster spin up. If my cluster isn't already spun up, then I have to, firstly I have to build a wheel onto my cluster so that my code is available on there, and then it runs my code on that cluster. So it does take a bit of time to test. Yeah, that's my experience with Databricks so far.
And can you talk a little bit more about any overhead or added complexity of using Fugue? Like it looked, I think, didn't look too bad, but I'm just wondering if there are any areas where it adds a lot of complexity or challenge.
Mm-hmm. I guess the only thing that you would have to overcome is learning some Fugue specific extensions. But other than that, you're still able to code absolutely in Python, and all you have to do is call on that function when you want to transform your data frames or even process your data frames. We have like specific extensions for those. But I think the added benefit is that you're abstracted away. You don't have to rely on whatever execution engine. Like when you're writing in PySpark, you're coupled to Spark. When you're writing a UDF, you're still somewhat coupled to Spark. So I think that benefit of learning Fugue is that you're agnostic to the execution framework that you want to run on.
That makes sense.
So,
thank you.
Yeah. So the overhead. So I guess the overhead you mean is the overhead for execution, right? So actually, we did some tests using large data sets. When this is running on Spark, the overhead is ignorable. So it almost not existed. Because Fugue tries to compile your higher level logic expression into the specific execution engine's logical expression as native as it can. So it minimizes any possible overhead during the compile. So it does not really add noticeable overhead on execution.
Great to hear.
Do you have any idea of the adoption rate of this? Like how many in the industry or how popular it is in comparison to, I don't know, something else?
I believe only Lyft so far. Yeah, I have thought about it personally for work. And I think where it would be very useful is, in data validation, doing data validation, just because the consistency guarantee in Fugue is actually pretty powerful, because when you do a join, let's say in Pandas versus when you do a join in Spark, you get different kinds of results. You might get different results. So that's something I've thought about, a specific use case. And another use case is, the cluster spin up as well. I think if we were able to run our unit test agnostic of Spark, that would also be very useful. So that's something I'm looking into personally for my workplace. But yeah, I don't know, Kevin and Han, if anyone has reached out to you yet, or any exciting use cases that maybe you can inspire others to think about at their workplaces.
Fugue has been extensively used inside Lyft on our machine learning workflows. So a lot of because we heavily rely on machine learning models inside my company, and as long as you are using a machine learning pipeline, you have to create a machine learning pipeline. You are very likely to consider to use Fugue as the backbone of your system, because it can significantly simplify your workflow. And another thing was to mention is that I thought about adoption. Fugue itself is a pretty new project, and of course there are not many people talking about Fugue as of now. But on the other hand, Fugue is the uniqueness of Fugue compared to, for example, Spark or Dask, is Fugue minimizes itself in your code. So in terms of adoption, so think about the adoption of Python itself, right? So because Fugue pushes your logic back to native Python. So as long as you are using native Python, as Megan showed in her demo, most of the code is just Python without anything to do with Fugue, right? And Fugue is just the last few lines of code. So that's the philosophy of Fugue. So if we're talking about adoption, I think probably it's not the best measurement for Fugue because Fugue pushes your code back to native Python. It's different from like other frameworks where if you have the dependency of, for example, if you have the dependency of Spark, you count it as adoption. But in Fugue, it's the opposite. If you don't have any dependency on anything, including Fugue itself, then it's an adoption. So it's very hard to measure Fugue's adoption.
Right. But the reason I ask is just because I wonder how is it socialized? You know, there are tools out there. I mean, there are endless tools out there. You sort of measure how much more it needs to be socialized by. It's sort of like a snowball. You know, as it builds popularity, it builds more popularity. So I was curious, as in the case of Fugue, how is it? I understand it's hard to measure the adoption, but how do you go about socializing something when it's so hard to know where it is, you know, to get a pulse of it in the industry? So that was the reason for the question.
Yeah, that's a good question. Actually, we have done a lot to try to socialize for Fugue, and I think Kevin can talk about it.
Okay.
Yeah, so we presented Fugue in like the Python conferences, PySpark conference, Python conference. We are seeing interest, like I guess like for example, official today, like we'll be having like a course with O'Reilly that we're working on for data validation through Fugue, and then it's just a matter of like we also have some content that we're continuously pushing out. I think over the next month or two, we will see like more so there's some bigger content map that we'll be pushing out. Although like we've already had conversations with people interested in using it, especially like to make packages that are cross-compatible with both Pandas and Spark. But we just have not like actually formalized like any of those like projects or anything like that. So definitely still looking for early adopters, seeing a bit of interest from some places.
Everybody here is an early adopter, so.
I wouldn't disrespect data scientists by calling myself anything close to that at this point. But I mean, I'm definitely interested in bridging the gap between DevOps and data science. So that's why I'm here.
That's awesome. Yeah, and I think Fugue also has a bunch of other projects going on. You know, when preparing for this presentation, I asked Han, like, do we see ourselves as, you know, just a feature engineering framework? And we totally don't think so. We actually extend beyond that as well. We have Fugue Tune, which helps you, you know, do hyperparameter tuning on machine learning models. So the philosophy definitely extends beyond just, you know, Fugue itself. Like it extends into the other projects that we have. So yeah, happy to talk to you more about how we can continue bridging that gap for you.
Cool, thanks.
Any other questions, or if not, then thank you, Megan.
Awesome. I like to give people time back. So here's another 12 minutes back to your day.
Thank you for the great talk and a little bit of time.
Thanks, everyone. Thank you.
Thank you.
Bye.